Waves at sea are oscillations of the ocean surface. They come in many shapes and sizes, ranging in length from a fraction of a centimeter to half the circumference of Earth, and can be caused by different phenomena. All these waves at sea can be primarily classified according to the generation or disturbing and restoring mechanisms or forces, but also by wave period, since forces induce oscillations within a wide band of periods and associated wavelengths. This is the most intuitive and commonly used classification of waves at sea or ocean waves. However, we can define another way to classify them, and this is according to the generation zone and to the depth at which they propagate or travel. In this lesson, we will learn about how they form and their basic characteristics. Next, we will deepen in its classification according to the generating/restoring forces, focusing on those generated by wind, and finally, according to the generation zone. The classification based on the generation zone will be discussed in the next lesson. As mentioned before, the most important in shaping the coastal zone are the waves generated by wind and the longer tidal motion generated by the attractive forces of the sun and the moon on the water masses of the Earth. Let's begin with wind-generated waves. The tides will be studied in further sessions. What causes waves? All waves, not only in ocean, begin as disturbances. The energy that causes ocean waves to form is called a disturbing force. For example, a rock thrown into a still pond creates waves that radiate out in all directions. Wind blowing across the ocean surface generates most waves at sea. The waves radiate out in all directions, just as when the rock is thrown into the pond, but on a much larger scale. Some of them will reach the coasts. However, waves can be created at the interface or boundary between two different fluids and travel over long distances. So we can find waves moving along the following interfaces. At the air-air interface, the movement of different air masses creates atmospheric waves. Atmospheric waves are especially common when cold fronts move into an area. In Mexico, cold fronts are atmospheric waves occurring during winter. Then we have waves at the water-water interface. Here the movement of water of different densities creates internal waves. This kind of waves are associated with a pycnocline, which is a boundary separating two liquid layers of different densities. Finally, the waves that are of greatest interest to us are those occurring in the water surface, known as surface waves, which are those occurring at the air-water interface. Here the movement of air across the ocean surface creates ocean waves, simply called waves. In the most general way, we can define that ocean waves are fluctuations of the sea surface where energy is a function of the height of perturbation. Other examples of waves are those created by mass movement into the ocean, such as coastal landslides or large icebergs that fall from coastal glaciers. Human activities also cause ocean waves. When ships travel across the ocean, they leave behind a wake, which is a wave. In any of the mentioned cases, energy is released to create waves. From the mentioned above, those created between air and water interface, the surface waves, are the most important to our course.